Welcome to the EZCODE Projects series Maze video number 1. In this video, we'll create our project directory and review what we'll be making. If you have not done so already, please complete the previous EZCODE Projects series setup videos to create our template directory we'll be using for this project. For those of you that have done so, let's begin. Find your EZCODE Projects directory. Mine is in Projects. Here's my EZCODE directory. We're going to copy the template directory we created in the setup series, and we're going to paste it in the EZCODE folder. So I'm just going to grab the template. I'm going to copy it, and we're going to paste the item here in the same directory, and we're going to rename the directory. I'm going to uppercase all my projects. You can do the same if you'd like. And we're going to name it Maze. Now, let's close this window and open up VS Code. Open the Maze directory. So we'll go to our Explorer Open folder. Here we're going to find our projects, EZCODE, Maze, and Open. So we just get the directory in our source code. Now open the code.js file and add the following changes. Okay, so let's go to our code.js file. Here we go. We have let's go down to greeting on line 9. And we're just going to change the greeting to maze so that we know what we're talking about. We're going to go down to line 11, greeting inner HTML. We're going to remove that. Go ahead and delete it. And let's get rid of our empty line. And then in the view append child, we're going to, of course, we changed greeting to maze. So this is now maze from the div element that we have created up here. And we're going to append that to our view container as we've done for many different projects. And we're going to do one more thing. We're going to add a new line right below here, and we're going to just make up a function call. We haven't created this function yet, but we're just about to. So let's go ahead and put a maze generator function here, and we're going to invoke it, and we're going to pass in the maze element that we have on line 9 here. So this maze element gets attached to the DOM, the view document, which is right here. If you remember, that's from our HTML that we've already created from the setup series. So this is the beginning one. We're going to attach a div inside of here. That is this one, the maze. That's how we're going to do it right here. And then we're going to pass that element in for further processing. And let's get a semicolon there in our maze generator function. So the next logical step, of course, let's create our function. So let's go down outside our load function, and we'll do the normal JavaScript syntax function. Let's call our maze generator. There it is. And we're going to pass in the maze, but I'm not going to call it maze here. This is the argument for the function. So everything contained in this function will reference this. And for now, I'm just going to call it element. Let's just be general like that. And then we're going to open up a new line and get our function curly braces. And now we've set up our project for the next step. So last thing we're going to always do is save our work. And now, how easy was that? Pretty easy for the JavaScript side of this. So now let's go to review exactly what we're going to make. Let's look at what a maze is. So we have a quick image here. Just going to open this up. We'll center it. And you know what? Let's get out of that for a second. We'll just make this a bit bigger. Okay. Now, this is the maze, at least something like this. And there's some colors at the top. And those are just to indicate what a cell is. So in this case, this would be in row 1, column 1. So for this image here, there are 8 cells across or columns. So 1, 2, 3, 4, imagine 5, 6, 7, and 8. And then there are 8 rows down. 1, 2, 3, 4, 5, 6, 7, and 8. So can we imagine the HTML structure we would need to generate to build this maze? So let's now, after looking at this, we can see that there's outer borders to this maze. There's an entrance, there's an exit, and there are what are going to be a random set of borders to each cell, which would allow for a path to be created. So how could we do this dynamically, where we can create a maze with the click of a button, in which case we can keep hitting the button and we get a randomly generated maze? There's a lot of information here. Where would the start be? Where would the stop be? How would the maze generate itself randomly so that it could still be completed instead of just having a border across the entire middle portion? So we're going to look at that as someone's already figured this part out. And here is a site from, it says on here, 2012. I couldn't find a name exactly on here to thank, but they are reviewing the Ehlers algorithm, and they state here that it creates perfect mazes, having only a single path between any 2 cells, 1 row at a time. The algorithm itself is incredibly fast and far more memory efficient than other popular algorithms, and it mentions them here, requiring storage proportional to only a single row. That's interesting. So we'll look at that in a second as we're reviewing this. And it goes through a section of the algorithm. We'll quickly go over this. If you'd like to further study this, you may. Here is the URL. And it assumes going in here, let's see, leftmost cells have a left wall, makes sense, and all rightmost cells have a right wall. So I'm actually going to bring up the image one more time. Let's put this on the side view over here. We'll just kind of keep it in the way just a little bit, and we'll go ahead and minimize VS Code so we can see what it's talking about. So the borders, yes, left and right borders, we can see that. Create the first row, no cells will be members of any set. Doesn't really make too much sense right now, but okay, there's a first row. It talks about unique sets again. Create right walls moving from left to right, randomly decide, we get that. Create bottom walls, again, randomly decide to keep adding rows or stop and complete the maze. We kind of get that. And what's really valuable here is the sample run that it takes us through. So none of this, you have to get none of this right here. We're going to piece by piece go over how to generate this maze, and this may become understood after some time. So even myself, I go through this. It's a bit confusing at first, but we go over things again and again, and that's what shakes out complexity, and we move towards simplicity. So to understand this, we have create a first row. It'll be an empty row. Great. Join any cells not members of a set to their own unique set. Pretty much just saying we're going to give a number that's unique to itself. So you wouldn't see a 1, 1, 1, 3, 4, 5 here. You would see each one is unique on the first row. And then what it's saying is we're going to go in and decide what we're going to do on the first row. So create the right walls. And what it's doing is showcasing that the algorithm or the code that we're going to build is going to look first at the current position. So we're going to start each row at the first item of an array, and we're going to examine the second cell next to it, and we're going to do the calculation on, are we going to have a random wall stuck inside of it. So the 1 and 2, it's really just asking, are we going to put a wall in between here or not? And that's a random decision. If the algorithm chooses randomly not to, then what it's going to do is add the second cell to the set. So in this case, it's pretty simple when you look at this thing here. It's just saying, look, if we didn't put a wall here, then this second cell is now going to become the first cell's number. So this was already a 1, and now this becomes a 1. So these are now, the set has increased by 1. Not the number 1, but there's now 2 pieces to a set here. And it's going to continue going down the line in the row. So now it's evaluating, this is our current cell, and it's saying, hey, the next cell, are we going to randomly put a wall there? And in this example, it says, no, we decided not to put a wall there. Therefore, the 3 is now part of the set from which the cell we were evaluating, the current cell, was a set, in which case it was a 1. So you can see we have 1, 1, 1. And then in the next one, it decides, yes, we're going to put a wall, and you can see the set does not continue. So now this remains the set that it was originally, which in this case was a 4. And then that's going to go on and say, hey, 4 and 5, what are we going to do? No wall. Oh, therefore, same set. What about 5 and 6? It's not a 5 anymore because the 5 became part of the set of 4, in which case it did do a wall, and so on and so on. The second part is the creating the bottom walls, and it has some rules here where it says ensure that each set has at least one cell with a down passage. Without a bottom wall is what it specifies here. Failure to do so will create an isolation. So that makes sense. If we had a bottom wall here as well, there's no way to get in or out of this section of the maze. So assuming each one of these, you can see there's at least one bottom wall. So again, we're randomly selecting, but also based on at the end, there must be at least one missing a bottom wall so that people doing the maze can get through it. The other section we could remember here as well, let's just imagine for a second that this 1 is not part of this set. Let's just say this is the number 29. And 29 is by itself. There is no other set, in which case any set that has one member of it instantly will never have a bottom wall because you can never get out of it. So just some criteria to look at here. It goes into creating a new row. And this is another piece we're going to have to revisit when we're going over the maze builder, in that after the first row has been built, which starts off as however many columns there are, each one being a unique set number, 1, 2, 3, 4, 5, 6, 7, 8 in that case. After it's been built, some of the sets might be matching. Like in this case, it has 1, 1, 1, 4, 4, 6, 6, 6. It doesn't matter what number it is. It's just trying to showcase that these are all members of the same whatever. The 1, 1, 1 could be the word banana. The 4, 4 could be the word purple. Just as long as they know, hey, this group is with purple and this group is with banana. Now what happens, and this is an interesting part of this, I might highlight this later on, is that the second row is built from the first row. So the first row gets unique sets, and then we run through it to provide the right and bottom walls. And then we duplicate that and give it to the maze generator as it already starts off with sets that may not be unique through each column. So that's an interesting point. I'm going to point that out as we're building. And what the algorithm says is right away remove all the right walls from the new row we just created. So no real stipulations there, just remove right walls. And it gets interesting here. If a cell has a bottom wall, remove it from its set. And what that's saying is it's going to run through. Of course, we're a duplicate of the first row, which did have bottom walls here, 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 and here. And you can see them down here. And what it's saying is if the cell has a bottom wall, delete the value it had in there for its set number. So in this case, these are no longer part of the set 1. This is no longer part of set 4, and this is no longer part of set 6. However, if it didn't have a bottom wall, they will remain part of sets if they were a set number. So once again, unique numbers coming in here. Then it says remove the bottom walls. Now run through it again and give unique identifiers to each one of the columns that in this case was empty. So join cells not members of a set. So there's a little bit of difference between the bottom wall generator and the right walls. In the right walls, we just deleted all the right walls. With the bottom walls, we had to first evaluate if it had a bottom wall, and then we're going to remove it from its set. So now we're going to go through the algorithm as it did before in the initial row, where we're going to add right walls. So we take the first current position, we start on the left, and we evaluate the left and then the rightmost cell, and we look for a random value of should we put a wall there or not. And it goes through here again, and you can see between the first ones, they decided, the generator did say we're going to do a wall there, in which case these were not merged as a set. And then it said no wall, and that's why we get these numbers. So you can see the algorithm, it's doing the same thing for every row with just a little bit of stipulations in between each row until it does it again and again and again and again until eventually you're going to have something that's going to resemble a maze. There is just one last piece they wanted to go over where the final row differs from regular rows, and we're going to go through that during the build phase. And once again, it should be something like this we should get in the DOM, in our document object model or our browser, and we'll see what we can do with that. So let's just, in this project series, we're going to attempt to create the Eller's algorithm using JavaScript, HTML, and CSS. And we'll build a way to generate a new maze with every button click in the browser, as we mentioned. And this is a little bit complicated just walking into it, but it's once we flush everything out, it might appear to be a little bit more understood by everyone. So we're going to try and do that during this project series. And nice work, everyone, for getting through all that. We've set up our environment for the project, and we reviewed what we are going to build. And in the next video, we'll start by creating our first pass at the maze generator in our code.js file. So if you've enjoyed this video, click like and then subscribe buttons to get notifications of new content. And thank you for exploring programming with me, and I'll see you in the next video.